All right, lesson 9-1, midpoint and distance formulas. So by the time we're done with this lesson, we should be able to find the midpoint and distance between 2 points. And this is a review from geometry. So here's our midpoint formula. Okay, so m is just the name of the point. So we're taking x1 plus x2, dividing it by 2, and then y1 plus y2, and dividing it by 2. Okay, so for our first one, we are supposed to find the midpoint of each segment. So it says AB, and it's telling us that A is -1, 2, and B is 6, 1. Okay, so I'm just going to add the x values together. So -1 plus 6, and then we would divide that by 2. And then we add the y values together, so 2 plus 1, and then we would divide that one by 2. So -1 plus 6 is 5 over 2, and then this will be 3 over 2. And for us, we're just going to leave them as fractions. So the midpoint for this is going to be 5 halves, comma, 3 halves. If we're given a picture, then we just have to identify the segment. So CD, so that's this side right here. So again, we could figure out what those coordinates are at. So that's going to be at 1, -1. And then D is at, see, 1, 2, 3, 4. 1, 2, 3, 4. So 4, 4. So again, we would add our x's together. So 4 plus 1, and then divide it by 2. So that is going to give us 5 halves again. And then if we add the y values, so 4 plus -1 and divide that by 2, so that will be 3 halves. Okay. Now if you have a picture, the other way that you can do it is you can actually kind of count. So if we make a triangle here, we would find halfway on this horizontal bar, so there's 1, 2, 3 spaces. So half of 3 is 1.5, so right about here. And then here we have 1, 2, 3, 4, 5 spaces, so half of 5 is 2.5, so I just count 2.5 towards the other way. So 1, 2.5, and then we would just kind of figure out where those points are going to meet. So right there, which again would be our coordinate 5 halves, comma, 3 halves for the midpoint. So. All right, the next part of this section is dealing with the distance formula. So again, here's our formula, and that comes from Pythagorean Theorem. So again, if we have a picture, we might be able to make a right triangle to make it a little bit easier to find. Otherwise, we are just plugging in our numbers into this and simplifying as much as we can. And we're going to leave our answers in simplest radical form. Okay. So again, looking at this, this will be x1, y1, x2, y2. So if I just substitute them into this formula, we will have d equals the square root of, and so we'll take 10 minus -4, so that's really 10 plus 4 squared. And then -7 minus -5, so again that's going to be -7 plus 5 since we're subtracting a negative, squared. And then we just simplify as much as we can. So that will be 14. And then if we just square it right away, 14 squared is 196. -7 plus 5 is -2. And -2 squared will be 4. So again, just continuing to simplify. So that will give us the square root of 200. So if we simplify that, we can split it as 100 times 2. So the square root of 100 is 10. And 2 would stay inside the radical. So again, this is our exact answer. If we wanted the approximation, then we would just take the square root of 200 on our calculator. So the distance for this would be approximately 14.1 units. Okay, so like I said, for this class, we are going to leave our answers in exact form when we can. All right, so again, the next problem, we are given a picture. So we're supposed to find the distance between GF, so that's from here to here. So for this one, if we wanted to, we could actually just create our own right triangle here. We could use Pythagorean Theorem, so I would just count this space, so that's 2 units. And we have 1, 2, 3, 4, 5, 6, 7, 8, so 8 units. So remember, Pythagorean Theorem, we have c² equals a² plus b². and our c squared is the hypotenuse. So here's the right angle. So GF is the hypotenuse, so that's our c squared. And then we would just pick one of those sides. So if I just plug 8 in for a, so 8 squared is 64, and 2 squared is 4. So that will be 68, and then we would take the square root of both sides. So again, for the 68, we would just want to decide if a perfect square divides into it, and it does. So we would split this as 4 times 17. Square root of 4 is 2, so that comes out. 17 is going to stay inside our radical. So the distance for GF, so I'm just replacing C with the name of our side, is 2 square root of 14. So again, this is our exact answer. And the approximation we would find by using the calculator and just taking the square root of 68. So this would be approximately 8.2 units. Okay. But like I said, again, for me, for my classes, I want the exact answers. And that's going to conclude section 1.